Hi everyone. For this week's lab video, we're going to be talking about the upcoming weeks and what is going to be due for both your poster and your paper. Right now, I'm looking at a page on Canvas, and I've put all the material into one page because it was kind of difficult to find out where everything was. So this is on a page called Projects in your Canvas shell. And if you look at the top here, what we're going to see is that you still have the guide to writing a scientific paper and examples of comments on a lab report. Okay, and this has comments on things like the method, the abstract, the results. And so you can link to either one of these papers within Canvas. Hopefully you've already looked at these. Now what I've added here, and it has been in other places, but now it's all in one place, is the poster tips. And so we can look at this guide right here, which is a paper, and that is on poster tips here. And so if we were to link to this, what we will see is that it's the do's and don'ts of poster presentation. And so what we'll find is that in terms of doing this, what we'll see is that it has some highlighted features. For example, style, format, readability, attractiveness all count. And so it has some do's and don'ts. First of all, in terms of the do's, you do need a tri-fold poster board, and you can buy that in a 28-inch by 40-inch size. It's 40 inches across and 28 inches high. And I would suggest that you get some spray adhesive also instead of using tape. Spray adhesive allows you to spray onto the poster board and put your graphs and or abstracts, pictures, things like that onto the poster board. And if you need to rearrange it, you can typically lift up on the piece of paper without ripping it and replace that. It's just better than glue. Glue seeps through paper. It's better than tape. It looks way more professional. And spray adhesive is pretty inexpensive. Okay. Now, in terms of don't make up your poster on one or two large boards. Okay. They're clumsy. They fall around. And so for us, we're going to be looking at 28 inches by 40 inches. Okay. Now, in terms of formatting, you're going to see here the type style, don't be too large or too small. And it says do make it easily read from 25 to 50 feet. Okay. And so essentially you want to have it so it's easily read. Couple other things, not too small, of course. This is the single most common error. Do not ever use 10 or 12 point. It's not good at all. Not have enough space to fill up all your text, then shorten your text. For example, when we get down to the methods, you're not going to want to write every single step that you did in the lab as your method. You're just going to want to do an overview. Again, I would not pick a font that is really funky. Okay, I would pretty much stay with like Times New Roman or Helvetica or Courier on a poster board. Absolutely no handwriting, no whiteout. Okay. So don't wait till the last minute and you have to add something with a Sharpie pen. Okay, not professional looking at all. Again, make it easy for the reader to follow your presentation. So you are going to use a logical order. For example, you would do abstract and then maybe an introduction to the problem and then maybe a methods section. And so we'll look at how we're going to do that. Now, in the logical order, we're going to do this in columns. So it's a tri-fold poster, so you want to read from vertically, top to bottom, and then left to right. And so you might want to number your poster pieces. You don't have to, though. But I would probably give them some type of label, like the abstract or the method, just so that someone can logically follow along. These are the same types of parts that will be in your final paper. Now you can use color to attract attention, but too much color distracts us. So do not make your font rainbow colored or anything like that. Only use color if you're bulleting key points, okay, or you can use bolded or underlining, but too much color is too much, okay? So make sure you're reading through this paper. Now, in terms of content, you do want to break it up like a scientific article, okay? It's easier if you label all the sections, starting with the abstract. Now, the abstract is not going to be exactly like it is in your paper, because in your paper, it's like 150 words, sometimes 200. You don't need that thing as long. And so you might want to pare down your abstract a little bit. Now, it says display your graphs. Okay, well, it says here right now, after the abstract, talk about your strategy, the methods, the results. Okay, display all your graphs. And then write very short legends for every single figure. So if you give me a graph, you better say figure 1 or graph number 1 is the absorbance of blah, 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 you know, something like that. Now, in terms of jargon-free, you want to talk about what is the question, okay? What are we trying to address? So for us, we're looking at the decomposition of aspirin samples, okay, to salicylic acid and determining the percentage of salicylic acid in these aspirin samples. And we're doing it by 2 different methods. One is using visible spectroscopy, okay, utilizing the Spec 20 instrument. And then, of course, in determining in terms of something like the absorbance of the salicylic acid in iron chloride. And then the other method, of course, is using the back titration with hydrochloric acid to determine the percent aspirin in our sample and thereby default finding the percent salicylic acid. Now, significance. Why should we care about this problem? And I think everyone has addressed this in their abstract. Something along the lines that, you know, over time, aspirin will degrade. Okay, and so there has to be some type of expiration date on the aspirin because we do know that over time it will decompose into salicylic acid and therefore not be as effective as a pain reliever and also cause stomach upset. Another reason why we care, of course, you know, we cared in terms of synthesis of salicylic acid so that we could make aspirin. But here we're just kind of looking at the decomposition over time in, versus samples. And then we're also looking at how the Chem 121 students actually synthesized, how well they synthesized their salicylic acid. Now our class synthesized it by recrystallization. Their class didn't. And so you might want to say something about how pure their samples are, okay, just relative to their percent salicylic acid. Now that salicylic acid is there from either decomposition of the aspirin over time or it is unreacted salicylic acid from when they synthesized it. And so they had a whole bunch left over. Their reaction didn't go to completion, so their method maybe not so good for synthesis. Number 3 here says, how did you particularly address this problem? And so in terms of looking at the percentage, we looked at 2 different methods. What did you do? Okay, again, you can talk about your 2 methods. What is visible spectroscopy? How did it measure the salicylic acid in the sample? And then also back titration to determine the amount of excess sodium hydroxide left over after your 2-step decomposition of your aspirin into salicylic acid. And so you can talk about those 2 things. And then what results? What did you actually find out? So I don't want any raw data on your posters. So calibration curves are out because we don't care. What we want to do is look at the percentages in your sample. What is your sample? What year and term was it? And what type of percentage did you get from the Spec 20 results? Okay, and how did everybody else fare in the class on those results in terms of the term and what their percentages were? What is that relationship between the age of the sample versus the percentage salicylic acid? And there may not be any trend at all, as you all know about that. And then also, you're going to be looking at your percentage of salicylic acid determined using back titration. Now, one of the results that we're going to look at is comparing our 2 methods from these 2 weeks. What was your percentage of salicylic acid using the Spec 20? And what was your percentage of salicylic acid using back titration? And what is the percent difference or error between these 2 methods? and try to explain the differences. If they're both identical, we'll say, hey, both these things got us the same exact answer. Probably not going to happen, guys. So then you want to explain, how does the titration reaction, what kinds of errors could happen in that would make it different than something like the Spec 20 synthesis. Also, another result that you guys will be able to talk about is comparing our class to Mary's class. So they will have identical samples as you, and that particular link is up in Canvas right now. I'll send you an announcement about that so that you can look at their Google Doc of our results versus their results. So what did they get for percent salicylic acid using their Spec 20? What did our class get? And you can look at the percent difference, okay? And then, of course, the conclusion then. How good are these methods? How well did the Chem 121 synthesize their aspirin? And can you say anything about the decomposition versus time? Now, as an optional thing, you can either say, what kinds of reservations do you have about these methods? Okay. Why do you think they're hokey? Well, okay, if you don't know the word hokey, why do you think they're not realistic? Or you can talk about future projects in terms of where would you go from here? How would you make this particular lab method better? So is there anything that you did in the Spec 20 lab or the back titration lab that you think did not give you good results? And so what could you do to improve that? And of course, always stay on point and be very, very brief. Not too many words. I would maybe use bullets on my poster and not complete sentences. Okay, just go for the key terms. This is not a scientific paper, so do not cut and paste from your paper onto the poster because it will be too many words. So we want to convey the big picture. And so if you do have references, and I know you will, if you take a picture off of the internet, let's say of salicylic acid, you must cite it. And these citations can be down in the lower right-hand corner of your poster as the very last thing that you would have on your poster. And of course, URLs for websites, very important. Don't leave everything to the last minute, because then you're putting things on there with felt tip pen, you're using whiteout, which we should never use, and God forbid you use tape. Now, it does say put your poster together early, pre-cut, the poster boards you can buy, but start by kind of laying them out. Next week when we get together for our 3-hour session, next week I'll have a classroom open, and so you can bring your poster boards and parts of your poster to look at layout, ask my advice, that type of thing. I would start doing this now. Now, during the poster session, which will be in 2 weeks from today, on February 25th, we're going to have the poster session in the room that you're probably going to be in next week so that people can walk, other students, and you can invite your friends, family, whatever. I'm going to invite other faculty members to come and look. And so you want to stand by your posters, not right in front of them, and answer any questions that anybody has about your poster. Another thing that you'll be doing during that 3 hours is you'll also get some time off from your poster to go and review 3 other people's posters. So I'm going to give you a rubric, a grading rubric, so that you can go around and grade other people's posters. Now, I absolutely know not everyone's going to get 5 out of 5 being the best score on every single thing on their poster. So do not go by your friend's poster and decide to give them 5 out of 5. I will probably assign you a poster in which to grade. But again, be critical, but also give good advice. Say, you know what, I really liked what you said here. Maybe your font's too small. But again, I don't expect that you should be giving me reviews for other students' posters as, all the points being assigned. Now, don't disappear from your poster unless you are released from that to go and review. And so some people will be released from a poster periodically. I'll come by and say, go review 3 other posters and then come back. Now, you can provide supporting material, okay? Last term in a poster session, someone had an iPad embedded or cut into their poster so that there was a small video running the entire time. Granted, it was for chemistry and art, and it was on paper making, that technique, but hey, it was really cool. Again, we probably aren't going to have anything like that for our poster session, but again, if you want to bring a handout or any auxiliary materials that you think are relevant, great. Okay, so this is this poster on poster tips. The other thing is going to be on, here we are. This is another link that we have. And in terms of going through our posters, again, font size, major, okay? So from about, I mean, it says in the article 25 feet away. In our rooms, we're probably only going to be about 10 feet away, but still, it's got to be pretty big. Not too much white space. Of course, do not add pictures if you're just adding them to fill up space on your poster. Because again, it is too much of the cheating way out. Now, you need to have that logical flow, as we said. Okay, we're going to read from up to down and from right to left. Okay, clear story. What are you trying to show? No raw data. Okay, none. So no masses of reagents, no beginning volumes of sodium hydroxide, ending volumes of sodium hydroxide, none of it. I don't want calibration curves, nothing. Okay, you have to give me the results. For example, what is your percent salicylic acid in your sample? Okay, the mean salicylic percentage, the standard deviation, things like that. Now, in your summary of your data, you want to compare samples. So you're going to compare your samples to Mary's samples in terms of if you have the exact same term, okay, as one of her students does. Also, you want to compare things like age, okay? How old is the sample and how much decomposition or unreacted salicylic acid can you say about it? Again, if there is no real trend, you have to say that. You want to give an overview of the methods. Absolutely no procedures. No list of materials. I don't want to see this again. They don't want to see it either. So if you're talking about methods, we're talking about visible spectroscopy, okay, utilizing the Spec 20. You want to say maybe what your blank is, okay, and back titration with hydrochloric acid. And just some general view of, you know, we're looking for an excess amount of sodium hydroxide so that we can determine the amount of aspirin in the original sample, and therefore the amount of salicylic acid. The images should be relevant. Do not put pictures in as space fillers, okay? Hello, I know you're going to do it, or you're going to try to do it. Don't do it. And of course, if we copy an image from the internet, you better cite the source, and that needs to be at the end. So on your tri-fold poster, citations and references go in the lower right-hand corner. Now, you want to be very aware of what kind of graph you would like. For example, when we were doing the age of the sample versus percent salicylic acid, the scatter graph's probably not the best. Maybe you want to use a bar graph, okay, and saying, okay, this is the percentage versus the age in months. I don't know. You're going to decide that. Maybe a pie chart. Nah, then again, maybe not a pie chart. Says don't use a line for independent samples. So if you've got winter, okay, 13 versus somebody who's got winter 12, line graph probably not the best. We haven't discussed that before, but now we're going to discuss it for our poster. Don't use a bar graph to show changes over time. So maybe we don't want to look at the age versus the percent salicylic acid. So we're going to have to choose. What do you think would be the best? Make sure on any relevant graph that there is a 0 timeline, okay, in terms of 0, 0, okay? And also make sure we have clear titles, okay? Again, we're not doing a calibration curve, but you may want to say the percentage of salicylic acid in various aspirin samples versus the age of those aspirin samples. Make sure there are units on all the axes and you capitalize all the words in the titles. Now here's the grading rubric, everything that we care about, okay? And this is what I'm going to be looking at in order to grade you. So first of all, this project, the poster, is worth 30 points. And of course, you're doing this as your team. The team needs to put together one poster, and again, that's due on February 25th. And so your team is going to be talking about the poster, and then people can go around the room as I assign them to leave the poster and be able to go and rate other people's posters. Someone will always be at your poster. So I'm also going to walk around the room and ask people who are at the poster questions so that I can see how well do you know the data and what your actual group did. Because if you only pay attention to your part of the poster and you don't know the overall story or overall results of your project, then I'm going to know that because I'll ask you a question and you won't know anything. So make sure everyone on your team understands the whole scope of what you're going for. So we want to make sure there's a clear conclusion, okay? What do your results say? How good are the methods? How reliable is your data? What is the percent difference between yours and Mary's class? Can you say anything about the decomposition of salicylic acid? Or were you able to even get a real value for that? Now, bad data is still data. And so if you don't get a clear relationship between decomposition and the age of the sample, you can say that. Now, you want to make your poster understandable to someone who is coming from a different class, okay, who's never seen this project before. And I'm going to look at it through those eyes. Also, the other faculty members I'm going to invite to this thing are not going to know anything about your project. And so you need to tell them in layman's terms, or as an ordinary person, what you actually did. Now, details are going to be omitted. Things like grams of stuff. Who cares? Okay? We don't care that you did 5 standards on a calibration curve. Again, don't care. What are the results? Make sure you don't have any spelling or grammar mistakes. So this is why I'm giving you some time. You can come to my office hours, go to the writing lab, or see a tutor and ask their advice about what is good, you know, in terms of writing. The other thing you can do is go to Snohomish, I think Snohomish is SNH, 126, and on Mondays from 12:30, man, I can write, to 2:20, I have study hours in there, but also on Tuesdays, Mary has study hours in there. So you can go ask Mary too. Okay, she's been doing this a long time also, and so Mary has her office hours around 12:30 or 1:30 on Tuesdays in Snohomish 126, and you can go ask her too. Now, graphs are going to be presented in an order to make a particular point. Okay, we're going to talk about decomposition, percentage, samples, you know, things like that. Main thing you probably have never done is captions beneath your chart or graph. So when someone looks at them, they can look at the title of your graph, but underneath it can have a little paragraph or a couple sentences that sums up what does this graph actually say to me? Okay, what does this graph actually say to me? All right, not just a title, but something like there is no real trend between the age of the sample and the percent salicylic acid, as shown in the graph above. Something like that. Again, you're going to be graded out on the logistical flow, layout, flow, how easy is it on the eye. And then, of course, the balance of text to graphics. You can't have one little box of text and every other thing on your poster be a graph. This is just not going to cut it. And so, essentially, we want to make sure that we're not using graphics or tables or anything like that to take up space. And, of course, appropriate font. So here are the point values that are going to be assigned to each one of these things. Okay? And so that is that particular link that you find in Canvas. And here are some more links that you can link to in this PDF file in order to see more places or more things that can talk about scientific posters. Now, so those are some poster tips, okay? Now we're going to go on to the paper. One of the links on Canvas, if we look over back to Canvas, is going to be the paper rubric and the project paper template. So if we look at the paper rubric, okay, this on the rubric does say Chem 142. We used it last year, but it is for Chem 162. And you're going to see on this particular file that, again, the abstract here is 6 points, introduction 10 points, and it shows things with individual point values, describes what you propose to do or test, briefly describes the methods. Okay, and we should have already gotten this. Okay, introduction. Okay, we've already written this, but again, your writing of your introduction was only for the Spec 20. You're going to also have to add in that back titration now. Same thing with the abstract. The materials and the methods, again, you want to look at those sample, how to write a scientific paper link on the projects page, and it will tell you what you want to do in terms of writing a method. The method we're handing in tomorrow on Thursday, but again, it's going to be for both the Spec 20 and the back titration. And again, we don't want specific amounts of things, okay? Not the exact amounts that you weighed out, things like that, but overall, in general, what did you do? I weighed out an aspirin sample, and I diluted it in ethanol, and then, you know, I titrated it with 0.1504, you know, molar sodium hydroxide to endpoint, you know, and then I added extra amount of sodium hydroxide to ensure that the two hydrolysis reactions went to completion, and then I back titrated using, you know, point whatever molarity HCl to the endpoint in order to determine the amount of excess sodium hydroxide left over in, you know, the beaker or what have you. And so then you want to talk about how did you find out the percentage of salicylic acid from there. So that's 10 points. Okay. The results are going to be 12 points. The results are in a paragraph form, and you're showing data in a way that clearly supports the point being made. What is the age of the sample? What is the percent salicylic acid percentage? We can talk about the purity of the Chem 121 samples, okay, from at least the percentage of salicylic acid present. And then we also want to look at comparing Mary's class to our class. How well did we determine our percentage of salicylic acid versus, let's say, another group that has the exact same term. And then we also want to look at the differences, the percent differences between using the Spec 20 and back titration to find the percent salicylic acid. So you want to compare both of those methods. If they don't give you the same answer, why are they different? And you must discuss the chemistry of why you think they're different. Of course, we're going to have charts and graphs well labeled, and of course calculated results and data that are error-free. Significant digits, of course, count, guys. And then your discussion clearly states your conclusions. There is no trend between age and percent salicylic acid. We can't say anything about, you know, purity of the samples, or yes, we can. You want to reflect on your results. Okay, this is how percent difference between Mary's class and our class. I think our class, you know, if there was not a much percent difference between the same term and percent salicylic acid with Spec 20 or back titration, that we successfully, you know, performed the experiment, you know, within human error. And something about if your results are very far off from Mary's class, then you're just going to have to be able to talk about what error you believe that you did in lab. And then, of course, specific sources of error. If you say, I think I wrote down a number wrong, not an error that we're going to accept. That the machine has error in it, not an error that we accept. It has to be something specific. Like, while I was titrating X, I noticed that there was a drop on the ends of the burette. It means that the volume of sodium hydroxide that I recorded was actually more than the amount of sodium hydroxide that was delivered. Therefore, it's going to affect the number of moles of aspirin. It will be too high or too low. Be specific because you can figure it out. And then because, let's say, the percent aspirin was too high due to that error, again, I'm just faking that, then my percent salicylic acid would be too low. But you have to go all the way to the end to the results. What does it do to your percent salicylic acid? Does it make your end result too high or too low? Now, sometimes air, you can't specify then if your resulting acid answer is too high or too low. But usually you can. Discuss implications, okay? What are the implications of synthesizing salicylic acid in the way that Chem 121 did? You can talk about purity. Do you want to be a company that does that? And then also the implications of how well did the Spec 20 results give us in terms of percent salicylic acid versus back titration. Okay? Are both of these methods equally viable, or is one better than the other, and why? And then, of course, you have to write this in such a way that it is not written as you speak. Okay? So do not write a paper with jargon in it. Okay, you're synthesizing something. You're not making something. You're using an instrument. No, we don't really want to use using. We might want to say the word utilize. Okay, you want to avoid using personal pronouns like I and we, our. Do not say this experiment. Say the experiment, because this is referring to what? Okay, don't say its melting point. Okay, because what's its? Okay, you might want to talk about salicylic acid. Don't say the sample. Say the salicylic acid sample or the aspirin sample. Again, come and ask me if you have questions, or Mary can also help. If you do not cite your website sources, okay, or any source that you use, it'll be 5 points deduction. If it's late, it's up to 10 points a day. And if you copy, cut and paste from the web, it is 25 points, or if it is an egregious type of thing where you have copied someone's entire paper, okay, then I'm going to award you a 0. There are programs out there that I can cut and paste from your paper, because I'm going to have you actually send me a file with your paper. You're going to print it out, and you're also going to send me a file so that I can just cut parts of your paper out, and I can put them into this particular document, and it will tell me exactly if you have copied it from a web source. Okay? And so please don't do that. I don't want you to lose points because of that. So this is the grading rubric. This is exactly what you're going to see on your paper. And when you hand in your paper, I would ask that you print this rubric out and staple it to the back page of your paper so that I already have it there, so I can just look at it and check off my points. And again, you have it then, so you can check off to make sure everything is in your paper. Now, the other thing that is on Canvas is the project paper template. Again, it's just going back to how to write a good scientific paper, and it's just kind of going through and just making sure and reiterating, you know, what we're going to talk about. Your paper is written on your own. Your posters are with your team, but your paper is your own grade. Now, again, I brought up the sample papers that we looked at for the abstracts down here. And so you can go and read them. You may not understand what they're about, but look at how they're utilizing words. Utilizing, not using, utilizing. Don't say that we want to find out the answer. You want to determine the results. Okay? They use specific jargon and words that are not usually used in everyday type of conversations. Okay? And so you're going to have to look at some samples. But this paper template, I have it right here. Whoops. And I'm going to look at this, and you have this in Canvas, so it'll be a little bit bigger. I'm going to make mine a little bit bigger. My awesome paper. Whoops, way too big. It's way too awesome here. Whoa, way too small. Way too big. Okay, so hold on. We got to